The next very important data structure in Python is called a dictionary. So for those of you who know algorithms and data structures, a dictionary in Python is like a hash table. Is like a hash table. If you don't know what's a hash table, it's perfectly okay. For those of you who know what's a hash table, it's basically we will come to it. We'll come to how a hash table works in little detail, not in full rigorous detail. But for those of you who know what a hash table is in data structures, if you have studied this, I believe most students of computer science study this concept in their undergraduate. So if you know what the hash table is, a dictionary is nothing but a hash table in Python. Okay. So let's see what's a hash table and how it works. Okay. The very important thing is a dictionary is an unordered collection of items. It's not ordered. So the moment it is unordered, you cannot index it. You cannot index it. So it's non-indexable. It's not ordered. Remember, your tuple is ordered. Your tuple and your list are ordered. Are ordered, right? Your tuple is immutable while your list is mutable, but both of them are ordered. While a Python dictionary is an unordered collection of items. Okay, we'll see. Let's understand hash tables and Pythons in little detail. Okay, so imagine if I want. So in a Python dictionary or even in a hash table in general, in any programming language or in general data structures, you have two values. You have something called a key and a value. Okay, you can think of that as a table that it's storing it in. Okay, one good way to think of a dict or a dictionary is you have a key and a value, right? You can store anything in the key. For example, let's look at this is like creating an empty dictionary. Okay, and dictionaries typically, as we already know, we put curly braces to represent dictionaries. So here I've created a dictionary and I've said, so dictionaries you create by giving key value pairs. So this is called a key value pair. So when you say this, so this is your key and this is your value. Okay, similarly this is your key and this is your value. And key and value, between key and value you have the column. Okay, so let's see how it works. The moment I do this, it says for key of 1 store ABC, for key of 2 store XYZ, right? So this is what happens. It's basically storing this data into a table. Okay, but remember, let's see how this table is useful, right? So this is what exactly is happening when I create a dict. It's creating a table with two columns. My first column is a key. My second column is a value. It's storing my keys in this and my values here. Let's see what is the power of dictionaries. Just give it a second. Okay. Now imagine. Oh, by the way, dictionaries can have mixed keys, right? So here my key is name and my value is my first key. My K1 is name. My value 1 is Satish. My key 2 is 1. Remember, this is integer and this is string. That's perfectly okay. My value 2 is a list itself. Okay, so how is it getting stored internally? Internally, you have your key value pairs like this. My first key is name with a value of Satish, right? And my second key is 1 with a value of ABC, XYZ. Okay, so this is what is being stored. So when you say my dict equals to dict, it's create an empty dictionary. It literally creates an empty table for you. Okay, so you can also create a dictionary. You can create a dictionary using list of tuples. Okay, this is a tuple, right? This is also a tuple, and you have a list. This is now basically a list of tuples. This is now a list of tuples. You can give a list of tuples, right? You can give a list of tuples and you can create a dictionary out of this. So as soon as you create this, my dict will have this. My dict will have my keys and values. My key 1 is 1, my value 1 is ABC, my key 2 is 2, my value 1 is XYZ. Okay, so you can actually, so what is this? This is a tuple and we have a list of 2 tuples and you can create a dictionary out of this. Okay, so one of the big advantages of a hash table or a dictionary is as follows. Let me try and draw an example for you. Suppose if you're storing a data, so let's take, I have my key and value. Okay, let's assume my keys, let's assume just for simplicity, let's assume my keys are name and my value is address. Okay, so I have name 1, address 1, name 2, address 2, so on, so forth, name k, address k. Let's assume I have stored this in a table. Okay, now if I say, see, this is the power of a hash table or a dict. Okay, this is where it is super powerful, or a dict. Now let's assume if I say, I want to find, now if I want to find the address, if I want to find the address of, okay, a user whose name is ni. Okay, so here you have ni whose corresponding address is ai, right? So typically what do you do if this was stored as a list of, if this was stored as a list of tuples, right? I could have stored each of them as a tuple. I could have, right, and stored them as a list. Then I have to go one by one. I have to go sequentially. I have to go sequentially, and I have to check one by one whether my first name is n1, my first name is ni or not. If it is not, I go to the next item. I check, is it ni? No. I have to keep doing it. I have to keep checking each of my names in sequence to find the address of my user with name ni, right? So which means it's going to take a lot of time. On the other hand, a hash table or a dictionary has a very nice way of storing this data. It uses some complicated and interesting mathematics. Those of you who have studied hash functions and things like that will understand this. So a hash table and a dict is stored in such a way that I can say, get me the address of ni, and it would get it to me without going through it sequentially. So it knows exactly where ni is stored. So it knows exactly the row in which the ni is stored. It knows exactly that without having to go through each of them sequentially, the way you would have to do if this data was stored as a list of tuples. Okay, so a hash table or a dictionary makes you search for something very efficient and fast, and that's why we use dictionaries a lot. If you ask me, dictionaries, I think, are, or hash tables are one of the most used data structures in the industry. I mean, most of the real world problems actually can be solved very elegantly and very fast using hash tables or dictionaries. Okay, so this is a very important point. The dictionaries can get you data that is there in a very quick and fast manner, while if you store it in any other data structure like list of tuples, it takes you significantly longer time to get that data. Okay, having said that, let's go and understand accessing. So since we know the dictionaries are very fast ways to access data, right, as compared to lists or tuples or databases. Okay, so now let's say, let's see how to access. So we covered how to create dictionaries. Let's see how to access elements in a dictionary. Okay, so imagine if I have a dictionary which is name Satish, age 27, address Guntur. Guntur is, by the way, a town, a very famous town for education in Andhra Pradesh. It has some of the oldest institutes of learning in science, mathematics, and engineering in Andhra Pradesh, probably whole of India. Okay, so now if I say my dict within square brackets, if I put name, okay, I'm saying find me, this is the key, right? I query using key and I say, get me what is the value corresponding to this. It immediately gets it to me very fast, and it says it's the value is print. Now if I say my dict degree, now the key here, the K1 is name, K2 is age, K3 is address, right? There is no key with degree, right? So when I try to print it, it gives you something called a key error. Okay, which means this key does not exist in this dictionary. That's what a key error means. Okay, so now let's see what the error says. Key error degree, which means degrees doesn't exist. See, by the way, the errors that Python gives are terrific. They're very easy to read, understand, and correct. Okay, so now let's go. Is there another way of accessing the value, right? Because we query using the key, and we get the value, right? So if I say get address, so the other way to do it is dot get. Dot get is a function in dictionaries which, if I give it the key, it will give me the value. And now remember, the key degree didn't exist. It gave a key error earlier, right? But if I use the dot get function, it will return you none. So it's always good to use dot get, because it will not raise an exception or an error. It will give you a value none, which means nothing exists. Okay. Now how to add and modify elements in a dictionary. This is again very straightforward and simple too. So if I have a dictionary with name, with K1 as name and value 1 as Satish, K2 as age, value 2 as this, k3 and value 3. Now if I want to add a new element to my dictionary, right, or if I want to update something, now I'm saying my dict name equals to Raju. So what's happening? Now it says my dict name goes to this, right? And the value that it has is Satish right now. It will replace Satish with Raju here. Okay, because name already exists. It's about modifying elements. Okay, now when I print it, I get name equals to name Raju, age 27, address Guntur. Okay, this is about how to update a value given a key, right? I can add a new key if I choose to. So if I say my degree equals to MTech, I think our Satish, our friend here, has a master's degree. It's not that I think, I'm sure he has a master's degree. So he has said that my degree equals to MTech. So now it adds a new value. So this will become my key 4 and this will become my value 4. Now when I print it, I have name equals to Raju, age equal to 27, address equals to Guntur, and degree equals to MTech. So this is how you add a new key to a dictionary. And this is how you edit you modify or update an existing value for a given key. Okay, now how do you delete or remove elements from a dictionary? It's again very simple. If you have a dictionary like this, if you say pop, okay, this function pop, and if you say age, right? If you say age, so it will remove, so what is the, it will return the value which is here 27. When I print it, I get 27 here. Okay, but it will remove. Now when I print my dict, the age is no more there. So pop is a function which will return the value but remove it from the dictionary itself. Okay, so this is the pop. There's another related function called pop item. Okay, for pop item there is no parameter here. Pop item will remove any of the keys. It can remove any of the keys arbitrarily. Okay, so in this case, when I ran it this time, it kept this key, it removed the last key, but it can remove any arbitrary key. So pop item removes one of the key value pairs from the dictionary. Okay, so let's go down and understand. Okay, then there's another way to delete, by the way. So here I have a dictionary called squares, where I have, for 2 I have 4, for 3 I have 9, for 4 I have 16, for 5 I have 25. If I say del, using the keyword del, squares 2. Okay, so this is the key I'm giving, right? This is the key. So it will go and find where is the key and it will remove this whole key value pair. So what you're left with is 3, 4, and 5 keys. Okay, so del is a keyword here through which you can remove one key value pair by using the key value. Or you can say squares.clear. It will remove all the elements. And when you say print squares, it just gives you an empty dictionary. Okay, so let's go down and understand. Okay, so, oh, by the way, there's a small difference here. So imagine if this was my dictionary. If I said del squares, it'll delete the whole squares. But now if you try to print squares, it will give you a name error saying that name squares is not defined, because you've deleted it, right? You have not just deleted all the elements in the dictionary, but the whole dictionary itself you've removed from memory. So it will give you a name error that squares variable is not defined. Okay, let's go and understand some methods which are very, very specific to dictionaries. The first method is dot copy. So when you say dot copy, you're going to copy the elements, you copy all of the key value pairs that you have. So from squares to mydict, and if you print mydict, you get exactly the same value as you have squares. The other very interesting thing, this is a slightly contrived example. This is a very slightly complex way of creating a new dictionary. Suppose I want to create a dictionary like this: maths 0, English 0, Hindi 0. Remember, the values here are the same. The keys are changing. My K1, my K2, and K3 are changing. In this case, what I can do here is I can say create a dictionary called subjects. Here I give an empty dictionary, because the function from keys, okay, is there for a dictionary. Okay, I create an empty dictionary here, okay, and say dot from keys, and I'm saying these are the keys, and the keys are there in a list. And for all of these keys, the value is 0. So whenever I say this, okay, so this is called this function from keys has a special way of giving this value 0 to all the elements in this list. So it gives maths equals to 0, English 0, Hindi 0. Okay. Okay. Now let's go down And oh, by the way, there is another way of doing it. Okay, so if I have a dictionary like this, and if I say subjects is the name of my dictionary here. If I say subjects.items, let's look at what it returns. It returns it returns us a it returns us a list of tuples. Okay, it's returning us a list of tuples. Okay, this is one way of visualizing a dictionary. Okay, so subjects.items will return me each of them is a tuple, and I'm returned a key value pairs as tuples, and this whole thing is returned as a list for me. Okay, the next thing is, if I want to just find out only the keys, if I want only the keys, okay, suppose I have a variable, I have a dictionary subjects with all of them. If I just say subjects.keys, it will return me just the keys. If I say subject.values, it will just return me values. Okay, similarly, if I create an empty dictionary and if I say dard, it gives me all the methods and attributes of dictionaries. So these are all the functions and attributes that I have of dictionary. Okay, we have seen some of them, right? We have seen some of them. We have seen pop, we have seen pop item, we have seen get, we have seen values, we have seen some of them. We have seen keys here, right? We have seen some of them. There are others also. Okay, next, just like our list comprehension, there is also a dictionary comprehension, which is very exciting. Okay, so let's go into it. Suppose if I have a dictionary like this, I can say pair in d.items. So d.items, right? d.items will give us all the items in the dictionary, right? When I say pair for pair in, so I can use for p in d.items, print p, then it will literally print tuples, where the first item in the tuple is the key and the second value and the second item in the tuple is the value. So if you want to iterate, if you want to loop or iterate through elements in a dictionary, this is one way to do it. Again, the in keyword can be used here, just like in list or anything. So when you say when pair in d.items, it returns you pairs of key value in a tuple, and it returns you tuples here. Okay. So the next very interesting thing here is our comprehension strategy. Okay. So let's say you might have a dictionary like this, A1, B2, C3, D4. If I want to create a new dictionary which has key column value, where the keys and values come from d.items. Okay, if the value is greater than 2. Okay, so what happens now? It will only pick the key values in my new dictionary if the value is greater than 2. So my new dict, if I print, I get only C and D, because for 1 and 2 the values are less than or equal to 2. Okay, this is a very good example of so this is a very good example. This is a very good example of dictionary comprehension. There is another way of doing dictionary comprehension. You can do more complex things. For example, if I have a dictionary D, which is A1, B2, C3, D4, E5, and if I say that I want to create my key by concatenating the existing key with the word with the character C, and I want to create a value by multiplying each of the values by 2 for key comma value in d.items if v is greater than 2, which means first it will go through each of them. So it will say this value is less than equal to 2, so it will not pick it. This value is less than equal to 2, it will not pick. This value is greater than 2, this value is greater than 2, this value is greater than 2. Look at 3, 4, 5, right? So now it will say, so you have C here, right? So how do I want to create the new dictionary? I want to concatenate C to this. So it will create a key with CC. And what is the value? Multiply whatever value you have here by 2, right? So you get 6 here. What is the second key? D. You concatenate C to it, you get DC. You multiply the value by 2, you get 8. Similarly, EC and 10. Okay. Again, dictionary comprehensions, just like the dictionary comprehensions, dict comprehensions are concise, but they can be confusing to people who come from other languages. So I personally use them sometimes, but I avoid them when I know that There might be people who do not know Python very well who might use it, or who might have to read this code. But it makes life very, very simple because you can write very, very concise, elegant code with